Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. We have already covered Azure Front Door and Load Balancer in detail during previous sessions. Please hit the playlist. With that said, let's dive into today's topic. Azure has Load Balancer, Application Gateway, and Front Door. At first glance, all three appear to do the same thing: distribute traffic. But they solve different architectural problems. So today we are going to answer one very important solution architect question. When should I use Load Balancer, Application Gateway, or Front Door? And by the end, you'll be able to choose the right service for the right architecture. Azure Application Gateway is a web traffic load balancer designed for application-level traffic. Instead of simply looking at an IP address and port, Application Gateway can inspect HTTP information such as the host name and URL path. That allows us to make smarter routing decisions for web applications. Think of it as a traffic controller that understands the application request. Here's one of the most important concepts. Traditional network load balancing operates around Layer 4 concepts such as IP addresses and ports. Application Gateway operates primarily at the application layer, where it can make routing decisions based on HTTP and HTTPS information. So remember, Layer 4 thinks about connections. Layer 7 understands web requests. Let's follow one request. The client connects to the Application Gateway frontend. A listener receives the request. The routing rule determines what should happen. The gateway selects the appropriate backend pool. Finally, the request is sent to a healthy backend. These are the building blocks I want you to remember: frontend, listener, rule, backend pool, and health probe. Now we get to one of Application Gateway's most useful capabilities. Imagine the user requests products. We can route that request to the product backend. Orders can go to the order backend. And images can go to a server optimized for images. This is called URL path-based routing. The gateway is making a routing decision based on the actual web request. We can also route based on the host name. For example, shop.company.com can go to our shopping application. api.company.com can go to our API backend. And admin.company.com can go to an administration application. So one application gateway can help route traffic for multiple websites or application endpoints. Now imagine Web Server 2 has crashed. Application Gateway continuously monitors backend health using health probes. If a backend is unhealthy, the gateway stops sending traffic to it. When the backend becomes healthy again, it can become eligible for traffic again. This is a simple feature, but from an availability perspective, it's extremely important. Another important capability is TLS Termination. Instead of every backend server independently handling the initial TLS connection from the client, Application Gateway can terminate TLS at the gateway. The gateway can then establish the appropriate connection to the backend. For sensitive applications, you can also design end-to-end TLS between the gateway and backend. This gives architects flexibility in how encryption is handled. Now let's add security. Application Gateway can integrate with Web Application Firewall. The WAF can inspect web requests for common application layer threats. This gives us a powerful architecture: application routing plus web application protection. And because we've already covered Azure WAF in an earlier episode, this is a perfect example of how previously learned services connect together. Here's the comparison viewers should remember. Azure Load Balancer is designed for Layer 4 network traffic distribution. Application Gateway is designed for web application traffic and Layer 7 routing. If I need to route orders differently from products, Application Gateway is the natural fit. If I simply need to distribute network connections across healthy backend instances, load balancer may be the better choice. Now let's compare Application Gateway with the service we just learned, Azure Front Door. Front Door is designed for global application delivery and routing. Application Gateway is generally positioned within an Azure region for application-level traffic management. And here's the important architect insight. You don't always choose one or the other. You can combine them. Front Door can provide the global entry point, while Application Gateway handles regional application traffic. Now we can combine everything. Global users enter through Front Door. Front Door handles global application delivery and routing. Each region has its own application gateway. WAF provides web application protection. Application Gateway performs regional HTTP routing. Behind it are our web applications, APIs, and services. This is how individual Azure services become a complete architecture. Now let's see this in the Azure portal. I'll open Application Gateway and focus on the architectural components. First, log into your Azure portal. Go to the top search bar, type Application Gateways, and click on it. From here, you can select an existing gateway or click Create to set up a brand new one. Once your application gateway is open, you'll manage it using the menu on the left. Overview. This is your home dashboard. It gives you a quick snapshot of your gateway's health, IP addresses, and resource details. Frontends. This defines how users reach you, setting up the public or private IP addresses that receive incoming traffic. Backend pools. These are your target destinations, like virtual machines, app services, or servers that actually handle the user requests. Backend settings. Here, you define the rules for forwarding traffic to those backends, such as using HTTP or HTTPS protocols and specific ports. Routing rules. This acts as the brain, connecting incoming traffic listeners directly to your backend pools. Health probes. Think of this as an automatic health checker. It continuously checks if your backend servers are healthy before sending traffic to them. Listeners. These sit at the front door, listening for incoming web traffic on specific ports, protocols, or hostnames. WAF. Your optional web application firewall. It inspects incoming traffic to block common web threats and keep your apps safe. Monitoring. Finally, use this section to track live performance metrics, check logs, and set up alerts. Let's apply this to our shopping application. A customer enters through front door. Traffic reaches the regional application gateway. WAF protects the web application. The gateway examines the request path. Product requests go to the product API. Order requests go to the order API. Payment requests go to the payment service. Now we are not just learning an Azure service. We are designing a real enterprise architecture. Now here's your architect challenge. Your company has global users. The application runs in multiple Azure regions. You need WAF protection. And requests to products and orders need to reach different backend services. Which architecture would you choose? The strongest answer is typically a combination of global and regional capabilities. For example, Front Door for global delivery and Application Gateway for regional Layer 7 routing, with WAF where required. Remember the golden rule. Load balancer distributes network traffic. Application Gateway understands web traffic. Front Door thinks globally. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.